The time series informations give you the temperature data through the time. For example, a point here on the tape or the tooling, the question is, what's the temperature history of that specific point? You measured it usually with experimental data via the thermocouple, and here we could extract those informations. For a specific point, what's the temperature history? To do that, we need to go to the global thermo. We select this plot. And now, because we have several plots on top of each other, we need to go to the object and select one object that we need to extract the informations. We select, for example, the tooling 4. We go back to the plot and update the plots. Now we have one object, which is here. What we could do is that select one point on it. Please note that with this one, on or off, we could add this point. So if you put this object on, then you could select a point on the object. When you select the point, XYZ location will be represented here. And then the next step is to click on time series plot. Please note that the irradiation zone button is off. When you click on time series plot, a plot will be represented. On this plot, you could save the informations, save the data, which save the data as a CSV file. And if you go to the selected plot, you could see that this one will be as ASCII file would be saved. You could open it with the notepad, and when you open it, is actually the data of this plot here. You could also use the brush item here to select a specific data and then save those data. You could copy the data to clipboard and paste it somewhere else. But what's the more important point here is that with this data, the temperature history, you could estimate the crystallinity with this icon, with this button. So if you click on this button, it asks you what's the initial crystallinity, relative crystallinity at the beginning. If you assume that your initial crystallinity is maximum, you set it as 1. But if you see that, if you think that your crystallinity started from 0, you could set it to 0. So with default value, we could click on OK, and this is a time step indicate that what is this time steps here. We have a solution time and what's the factor of time here. So without changing any of the default values, we click on OK, and this is the relative crystallinity that we plotted. Started from the maximum value, we have dropped here because we melted this material, and then we have a little bit increasing of the crystallinity because we go through this region of the near the melting point and the crystal can be formed. Please note that the constant material parameter of the crystallinity it could be added via the main window of the software, which is located at the crystallinity tab and the Avrami constant. You could change the information regarding the nucleations, activation energy, and other parameters like glass transitions and the melting temperature here. So when you change those informations, you could expect a different plots. But how about here if we have a different time step? Imagine that we have a similar temperature pattern, but we have a different time step, for example, time step of 2 seconds. Then we have the result something like that. So this was for that specific location. How about if we go to the other locations or even other objects? So we are in a tooling 4, and how about if we go to the, for example, tooling 1, tape 1. So if we go on tape 1 and again select the 1 point on the object, and again check on time series plot. Now we have a different plots like that for on tape 1 on this location. And if we click on crystallinity with the default values, we get the crystallinity like that. So this is useful tool that you could use it to extract the information thermal history and then quickly check the crystallinity progress of the case. What other information you could get if you click on irradiation zone? You get the informations of the maximum on average temperature or minimum. And if you click on time series plot now, with this irradiation zone selected, you get the overall temperature analysis, like for the irradiation zone. So this is the irradiation zone temperature for the maximum value, minimum, and for a substrate and tip. So I select only, for example, the average value that you see, the progress of the temperature of the irradiation zone. So see, we have a relatively steady temperature at the irradiation zone, and then at the end we have a little bit increase, and then this is for the different layers. You could again select the selected informations and extract the data from here. So you could perform this extraction of the data for the COT and UOT analysis. For the global thermal, this is based on the stationary situations. So you extract the data for a specific point. And for the UOT analysis, you have the local irradiation zone and local conservation model. So those points are Eulerian points. So for example, we get the data of the knee point through the time. You could extract those informations, but it's not for the crystallinity prediction. Only the global thermal data extraction is useful for the crystallinity estimations.